Hey folks, Winston for Carbide 3D here. If you assemble a Shapeoko 5 Pro with care, 99.99% of the time, you're going to end up with a machine that performs well and cuts what you ask it to. But in certain cases, it may be beneficial to take an extra step and dial in the perfect perpendicularity of your X and Y axes, super squaring your Shapeoko if you will. This would mainly be something to look into if you plan on machining very large parts, particularly ones that need to fit together with other pieces or are machined on both sides and you need features to line up. If you're already happy with how your Shapeoko 5 Pro is performing, there's no need to do anything. Just keep on using the machine, enjoy it. Feel free to skip this video. Just make sure you hit that like button before you leave. But if you do want to go down an accuracy rabbit hole, stick around. The Shapeoko 5 Pro includes a feature known as dual Y homing. On each side of the machine, there's a proximity switch located at the rear of each Y-axis assembly. These switches ensure that each time you initialize the machine, the gantry is set at a consistent position and orientation relative to the rest of the Shapeoko. If, when you built your Shapeoko, you took care to make sure the frame of your machine was assembled with equal length diagonals, your machine is already pretty dang square. But sometimes you might need every bit of precision you can get. For example, I'm building myself a rolling cart for my garage shop, and the design has multiple plywood panels that need to come together to make the design work. If each of my cut pieces was slightly out of square, shaped like a parallelogram even just a little bit, I would end up with gaps between my panels no matter how many clamps I used when building my cart. I need my Shapeoko to be not just pretty square, but super square, and we can easily adjust the machine to make that happen in just a few minutes. Here's what you'll need. First, we'll need some scrap material to make some test cuts in. I'm using 1/2" MDF. Second, we'll need an end mill to machine these test features with. I'm going to use a 1/4" down cutting end mill. Just because this is a throwaway test cut doesn't mean we need to accept fuzzy MDF edges. And third, we need a 90-degree reference, a shining beacon of truth for perfect perpendicularity. Now, there are many kinds of squares out there, and you can use any kind of square you want, but at the end of the day, it needs to be a square you can trust. You're going to be calibrating your CNC against this. For most people, a 1-2-3 block or a granite square is probably a good benchmark. Side note, I would not recommend a digital protractor here. It might look super accurate because it measures down to 1/10 of a degree, but here you can see just how big a margin of error a 1/10 of a degree really is. We can do better. The first thing we need to do to assess our machine's squareness is mill out a test feature. I designed mine in Carbide Create as an L-shaped pocket. In MDF, this thing can be machined in a minute or two tops. Once this pocket is carved, I can align one side of my square with the axis I take to be my ground truth, and that's the Y-axis. The Y-axis rails will always be fixed in direction. It doesn't matter if your machine frame wasn't built square, they will always be parallel. If they weren't, your machine probably wouldn't be working and your gantry would be jamming at either the front or the back. And side note, your frame not being perfectly square won't prevent you from being able to get your X and Y axes perpendicular. The X axis is the variable here. So back at the machine, I'll line up my square with the cut in the Y direction, and I'm using a 1-2-3 block to help get my granite square aligned. Now, how well the front edge of the square lines up with the machine pocket will tell me if the orientation of my gantry is off at all. And although this can be pretty subtle, trust your senses. You can eyeball or feel a gap of just a couple thousandths of an inch. Depending on how well your machine pocket deviates from quote-unquote true square, you'll be able to see which side of your gantry needs to move forward or back. How do we make that adjustment to the gantry, you might ask? Well, follow me to the back of the Shapeoko. The Y-axis homing switches are installed on sliding mounts. By moving one switch forward or backwards, you can advance or delay the moment when that side of the gantry triggers the homing switch during initialization. From my test cut, I know the left side of my gantry is farther forward than the right side by a fraction of a millimeter. I can either bring the right side of the gantry forward or send the left side back. I'm opting to do the latter in this case. To do this, I'll first loosen the 2 screws that lock the sliding action of the switch mount. You only need to loosen them, not remove them. Then I'll tighten or loosen the M3 socket head screw at the back of the Y homing switch assembly, depending on if I want to bring the switch forward or backwards. The mechanism here is spring-loaded, so it'll follow the socket head. Since this is a regular M3 screw, that means one full rotation of the screw will move the proximity switch 1/2 millimeter. I don't recommend making more drastic a change than 1mm at a time unless your gantry is badly out of square. In my case, I'm going to back off this screw by a mere half turn before retightening the locking screws and testing again. Before I can cut a new test pocket though, I need to reinitialize the machine so the gantry is reset according to the new position of the Y homing switches. You can either turn the machine off and back on again, or go into the built-in actions in Carbide Motion and select Reinitialize. I also need to re-zero the machine so that I can cut into fresh MDF to make my test feature. I'm going to use the rapid movement shortcut to get back to my previous XY0, jog northeast by 1mm, and then set this position as my new 0. You can run the exact same program as before, but since 99% of my MDF has already been machined away, a shortcut is to export a new program that uses a contour operation instead of a pocket operation. This time, when I set my granite square against the MDF, there was no discernible gap on the face parallel to the x-axis. For all practical purposes, my x and y axes were as perpendicular as the faces on the granite square. For the engineering and math nerds out there who crave quantifiable metrics though, if you assume that the average human can feel or observe a difference of 2 or 3 thousandths of an inch, and I'm scanning across 9 inches, that means my Shapeoko is square to within 2/100ths of a degree, better than what you can do with a digital protractor. This is a super square Shapeoko. At this point, you're basically guaranteed that anything you machine will line up with or fit against whatever it needs to. In my case, after squaring my Shapeoko, I was able to assemble my plywood tool cart without any issues. No parallelogrammed panels here. I hope you guys found this video helpful. If you run into any other issues with your Shapeoko, feel free to reach out to our support team. We're always here for you. Otherwise, good luck and have fun machining, folks.